Okay. Hey, so during both the breaks, I've had a couple of students who have come up and said, "Hey, I'm trying to," who have had difficulties with. Let me see if I can find it, with this step right here, with the push dash mirror. So when they try to do that, are you getting like a permission denied or something? Okay, I saw at least one student who was able to do this. Have other people been able to do that push? Oh, darn. Okay, any idea of, did anybody experience, oh, I couldn't do it, now I can?
I think it's the SSH
versus HTTPS.
SSH versus...
Like you can clone, or like, yeah, if you go to the actual like GitHub, look at it, you can either clone using like SSH or HTTPS.
So maybe replace this with HTTPS?
Just to ask anybody that is getting that error, is the error message specifically 503? Because if it is, that just means that you did not authenticate with GitHub at all. Which means get your SSH.
They were saying permission denied, so I don't think it was just a straight up 503.
Well, it's like 503 permission denied.
Oh, maybe?
And I make a lot of mistakes.
But yeah, I think
Git user was replaced.
yeah, your GitHub user.
I make that a lot.
So, oh yeah, maybe try HTTPS here instead of Git. I don't know. Can you? That'd be unauthenticated.
So like I didn't have the public key, and I switched the HTTP.
Yeah.
For this step though, for the push.
I just stopped doing that.
I'd be surprised if you could do a push without, because the HTTPS will not authenticate. I don't think. I don't think it would authenticate via keys. Maybe it would. I don't know.
Then it prompts you to put in your username.
Oh, okay. Then that's probably how it authenticates. Okay, so then people who are having problems with that, could you try it instead? Delete the git at github.com and replace it with the HTTPS. So it's HTTPS : that, and see if that makes any difference.
Is there a functional difference from doing this?
Sorry, wait a second, one at a time. Yep.
Is there a functional difference from doing this and just forking the repo?
Very good question. Someone else asked that. Oh, can I just fork the repo? You can't. And someone said no. Why can't you do it? Or rather, you can do it, but why wouldn't you want to do it? You can't make it private, right? So you could fork my repo, and as a matter of fact, if you want to contribute changes back, please do fork it. However, if you fork the repo, it's going to be public. You can't make a forked repo private. And if you put all your source code in there and it's public, that's not the right thing to do. So, so please don't use a fork.
Because you're worried about
Code of conduct.
Yeah.
Code of conduct wise, do you care if we make it public anyway?
I do, because I don't want anybody. Right. Please don't make it easy. I'm a big proponent of open source software, but there's a time and place for it. This unfortunately isn't the time and place. And please don't make it public. I only have 3 versions of the assignments that I rotate through, so I discourage you from making it public afterwards. While your code is very nice and everything like that, this isn't the code that's going to get you a job. Okay, so it's like I can write to a file, right? Okay, so yeah. A good deal. Or you can, you can always, seriously though, I mean, you can share your private repository with other collaborators and stuff. If like someone's trying to hire you, you just can't, make it public, please. Has anybody who is having the problem with authentication tried with HTTPS? I know you were challenged. Did you try with HTTPS and it still didn't work? And you can push to other repositories? Crap. Okay. Okay, I'll think about it. I don't want to debug it all now. Maybe we can do it at the next break, or maybe we can do it after class or something. Or maybe we can do it via Slack. Okay, where was I? We were writing unit tests, and unit tests are neat. What else do I want to talk about? I think I want to talk about the cones next.
Oh, real quick.
Oh, yeah.
I didn't get a Slack invite. I was wondering if anyone else did.
Are you registered for the course? Okay, I believe I sent an email to everybody. Well, maybe you registered after I sent the email. Okay, well, here's what I'll do. I will...
I sent you an email.
Okay, well, I'll reply. Yeah, so send me an email, and I can just send you the link. And then... Yeah, that'll work. Sorry. Okay, let's talk about the cones next. So we're going to come back to our student class. We're going to write some more unit tests. Actually, I'll probably see some different kinds of tests in a little while. Okay, the cones assignment. So,
Update, we did get it to work with HTTPS thing.
oh, HTTPS did seem to work? Okay, so then please file an issue in the Getting Started repository noting that, and I can change that. Clearly that seems to work. Yeah, I mean, I suppose if, yeah, so okay. That'll be good. Oh, yeah, right, and this is another thing, nice thing about GitHub. Actually, somebody, you already did, please file issues in the repository saying, hey, this could be improved, or hey, remember in class we're talking about this thing that was totally wrong, please go and fix it, and that way I'll remember it. And or hey, if you want to make that fork the repository, make the change, and submit a pull request. That would be super awesome. Because that way all I need to do is press a button. And I'm lazy and overpaid. Anyway, I'm not overpaid by PSU, by the way. Okay, so now I don't lecture you much on the Java language itself and the APIs, right? There's all the slides and everything like that. I show you a bunch of code. You can see me using it, but we don't really go into a deep dive. But there's a lot of interesting things. There's some nuance to the language, and there's some interesting things worth learning about. And to get you experience with the Java programming language itself, there is an assignment called the Java Koans. So a koan is a teaching question from Buddhist discourse. And the whole idea is that these koans show you features of the language or features of the APIs in very small bite-sized little chunks. They're a lot like unit tests. They're meant to be very small pieces of code that teach you about a specific aspect of the language or the API. There's this guy, Matt Bentley, who has written a whole bunch of koans. Actually, other people have contributed to them too. I use them for our own evil means. It's really cool. I've been using this for several years now, and while there's a lot of them, the students have said that, okay, it's really helped me understand some of the more advanced and intricate parts of the language. So there is, going back to our Getting Started repository, there is a script called create koans. Oops, grab my student ID. That will run the big ugly Maven archetype command line here. So instead of you having to type in all of that, the script does it for you. And I'm sorry I didn't update the assignments with all of this. I literally did this last weekend. I'm like, I should do this for the students. And this is why it's kind of all hacked together and has problems with like the Git URL versus the HTTP URL. And so I think that's already started to cause some confusion. And for that, I apologize. But with one command line, now you get a koans directory, which has all sorts of good stuff in it. So I'm going to add the koans to Git. And oh yeah, I didn't do all that. So let's see here. And so now I'm going to say git commit -m added koans assignment. Add koans. All right, all those are going to be added. Git push. Git status. Okay, good. You know what? So I'm going to take a quick aside here. I'm going to show you something. So a couple of other people were showing me this. There are some files here that should not be checked in to Git. The DS store, that's some Mac OS file system thing. The idea directory and the student.iml are all stuff from IntelliJ, and then the target directory is the Maven, contains all of the Maven built artifacts. Now in Git, there's I said there's code in there are files in your directory that you want to be in Git, like your source code and like anything that needs to be used to build your project or shared with other people. But like the artifacts that are built by the project itself shouldn't be. So I want Git to ignore all of this stuff. Now the way I do that is that there is a file called gitignore, which lists all the different kinds of files that that you want. And this gitignore was put into this directory, into this repository by the Getting Started one. So let's see here. So like here, if I go up here, there is a gitignore that has all of this stuff. Now, I want to ignore all of these files right here. So here's what I'm going to do. I'm going to change my git ignore in like the master repository, the upstream repository, all of the getting started one, and then we'll see how we can propagate it down to my clone of it, and then you can all get it too, so that you don't have to suffer like I do with git file with files that Git thinks should be there but aren't. So one of the cool things about GitHub is that you can edit it right there in GitHub, and so we'll put IntelliJ files in here. IntelliJ files, and that will be what? That will be the .idea, so a .idea directory and anything .iml, and then there's Maven files and anything called target, and oh yeah, and then Mac files, Mac OS file system files. I just like to explain what these things are, just in case anybody doesn't know. Like me. Cool. And I can commit it right there. Ignore more file types. Yes, commit directly to the master branch, which usually you don't want to do, but hey, I'm the professor. Normally what I should do is I really create a pull request that I then approve and whatever. Fine, so commit changes. Commits it right to the repository. So now if I see it, great, ignore more file types. And now, now I think okay, so let's see here. Right now, so this is my summer 2019 repository, a different repository from the one I just changed. But remember when I did, and you probably don't, previously I did this git remote add upstream to the other thing. Well, now if I do a pull upstream master, oh, and by the way, just to remind you, my git ignore ends with the Emacs files. Now if I do an upstream master, it pulled down some stuff. It's like, oh, look, you merged some stuff. Do I want to comment more on that merge? No, I don't. I'll just go do that. It now merged git ignore, and now it's got my changes. If you set up the master, the upstream, if you set up the upstream remote repository and pull from master, you too can get these changes. So this is a way that I can make changes, like as we're learning here. Oh, there are more things we should add to the getting started repository. I just made a change, and now I'm able to share it with all of you. Give it a try, and let me know if it works for you. I hope it does, because this is a way like I can. Oh, it does! Yay! Okay, good. And now, so as we're discovering things and we're finding bugs, we can all share it. Anyway, neat, right? GitHub, modern software, development. You're getting your money's worth. I don't know. No, you're not. Okay.
Sorry.
Back to the cones. I know it's a lot of money. Anyway, it's a good investment.
Right.
Yeah, no, in this field it is. If there are a lot of other anyway. Okay, so we got the cones. Let's look at actually let's quick do a Maven exec for the cones. I've got our old friend the Maven wrapper again. Oh, actually, I need to make it executable first. Now I can use Maven wrapper, and I can say what exec Java. Okay. The Maven. So sorry. The Koans have like this little runner thing, and so it runs there in the background, and it's telling you, hey, the first Koan is this thing called about Koans. So let's open up an IntelliJ, the project. Let's open up a new. No, sorry. Open, and we will open the. Oh, why is it put here? PSU get Koans. This directory. Where's the pom.xml? Oh, where's the pom.xml? That's weird. Thank you. Why? Wow, what kind of order is? Oh, it is alphabetical. No, it's not alphabetical order. Oh, last modified. Okay. Open as new project, open a new window. I don't want to import the Gradle project. Okay, so there's this little command line program running right now that is giving you feedback on your cones. And so this is, I think, supposed to be like the sensei who's, and I'm probably butchering this, sorry, who's telling you about, oh, hey, there's stuff to be learned here. So it's like open up the about cones file, and there is a method starting with @cohen called find about cones file. Look within it for your first lesson. Okay, so now let's go back to IntelliJ, and we define the about cones. If you use, go to file, shift command N, and we want about cones dot Java. I wonder if the app directory is there. That's bad. Sorry about that. Okay, here it is. Okay, so I'm going to hide this over here so we can see it better. Okay, we've got a class called about cones. There's the it's find about cones file. It is calling a method called fail. It says delete this line to advance. Okay, so I shall. Now when I go back to my my command line, it reloaded and it said, aha, okay, you did the first one. I've done the first out of 271 cones. And now what's the next one? Okay, it's considered complete when it no longer throws an exception. Often there is more than one way to solve a cone, but only one correct way. Often hinted at within the cone itself, one of the comments appearing here. So ponder what's going wrong in the definition of cone complete method. Definition of cone complete. Okay, what's going wrong?
Cone is complete as false.
How can I complete the cone?
Switch to true.
False to true. Go back. IntelliJ automatically saves the file when it loses the command focus. Aha, okay, great. We've gone on to the next one. So now we've done 2 out of 271. Now let's see here. There's a class called about assertions. Okay, so now we can use that Control Shift N. Actually, just use Command N. About assertions. Okay, what does it say? There are underbar that are an attempt to communicate the need to fill in an answer. Judging by context, what should underbar be replaced with? To replace this with? True. Moving on. Yay, we've done 3. Okay. It expected false, but was replace me. So here it expected false, but it was underbar, so we should have. Okay, you're starting to get it. This one should be no. Don't worry, they get more interesting. Okay, assert null object is referenced. So what should some object be? Underbar should be null. Okay, assert not null. Okay, this will actually, let's make sure everything's progressed. We've gone from 3 to 6. Good. Okay. This one is currently failing. Okay, so we need something that's not a null value. So 1. 1. Does that work? 7. So this is all the easy stuff. Okay, it's starting to get a little bit more interesting. Okay, what should be here? Okay, and this first one is just teaching you how to use the cones. This is not the, teaching you a lot about the language. That one work? 8, yep. Okay, so a whole bunch of equals. So this is basically teaching you all about these, about the various assertion methods. It's a lot like JUnit. So let's see here. Hello world, and 1, 2 plus 2 is 4. Okay, 6. 3 minus 8 is minus 5. 10 divided by 2 is 5. From 8 to 9. Okay. So there's other kinds of assert equals. So I'm just going to blow through all of this. Actually, this next one's kind of interesting, so make sure I got that one right. 10. Okay. Assert same instance. So, okay, we've got original here being a new integer. We assign it to same. So assert equals. Original and the same are equal. Original and same are also equal, but are they the same object? Sorry?
Say it again.
What is the same object as original? Is different the same? They are equal to each other, but are they the same? Why are they not the same? I mean, they're both integer 1. They don't reference the same object. Exactly. Yep. So original is actually. So if we said original is the same as same. 11. Yay. Okay, and then not same. So I guess we need to change it here. Expected 1, but was 1. Yes. Even though they print out the same. We need to make a change to this so that they are not the same. Wait a second. Okay, so original and the same are equal. Original or different are equal. Original and different are not the same. Yes, and now we're on to about equality. So, equality. Okay, and this is all similar stuff in terms of looking. Is this how? And so these are how the cones teach you about different aspects of the Java language. Here we're learning all about equals equals versus dot equals. There are ones that have to do with numbers. There are ones that have to do with methods and overloading versus overriding, all of that good stuff. My experience has been is that you get through these pretty quickly, but there are a lot of them. And so this is an assignment that I want you to work on over the first couple weeks of the course. And oops, Google Plus community. We're up. And so this assignment is due on July 24th. So whatever that is, 4 weeks. I recommend that you just do a little bit of this assignment every week. So here again, 4 weeks, try to get a quarter of it, or actually you probably want to front load it, with assignment 1, because it'll teach you about the programming language, right? I mean, you'll get more experience working with Java through the cones, and then you'll be able to apply that in your first projects. Later down here in the assignment, I talk about how to submit it and everything. We'll deal with all that next week. We just don't have time for it tonight. We'll come back to it. Questions about the cones? Yeah.
It's not happy with Java 12.
It's not happy with Java 12. Oh, really? Interesting.
What Java version do you have?
I probably have Java version 11. I have had more problems with Java 12.
Well, I feel like I'm gonna have more problems.
Oh no, it says I'm using Java 12. What didn't it like?
Let me just scroll.
Okay.
It says failed with an exception. Could not determine Java version from 12.0.
From Maven or?
Gradle, W.
Don't use Gradle.
I use Gradle. Sorry.
Use Maven. I should do that. I should get rid of that then. I can totally do that.
I got it from somewhere.
You pick up these things on the streets, right? A little bit of Gradle. No, so Gradle is an alternative, and I think from many people's opinions, points of view, a replacement for Maven. You can watch the Maven lecture, and you'll see there's lots of XML, and yeah, it's pretty restrictive. And for some people, for some Java projects, that's not sufficient. They want to have a lot more flexibility. They want to be able to do sort of like general things. Gradle appeals to a lot of people. I'm not entirely sold on it. At work, we use Gradle. Okay, I get it. I think Maven is better for what I use it for this course. I really like the Maven archetype that we really didn't talk about because I've hidden it from you from the scripts. But that makes my life a lot easier to use Maven archetypes. The Android stuff, though, we're going to use Gradle. I don't think you're going to need to know anything about Gradle other than just type this command. That will build everything. But that's what Gradle is. It's an alternative to Maven. Yep.
It works fine.
Oh, good. Is it better with Maven? Yay. Okay. Oh, I made some changes to Maven W in cones. Oh, it's probably contents are identical. Okay, lame. So I will revert those changes, whatever those are. It's probably line endings or something like that. And then we'll just add some cones. Okay. Good. And now we will, let's see here, we added another unit test. Oh, weird. Oh, because I closed it. No, I didn't. This is the wrong project. I want the cones project. I want this one. Okay. When GPA is greater than 0, throw an exception. Greater than 4. Did it again. Commit and push. Okay. We saw unit tests before, and unit tests are meant to test a unit of your program, meaning a class or a method, sort of the smallest parts of your program, right? And this is really good because it helps you explore your interfaces. It demonstrates that you can solve the little problems, the contract that each class provides, right? A class provides, you want your classes to be encapsulated. You want your classes to do one thing and to do it well. Actually, that's an Uncle Bobism, right? He talks about, you want to have, you sort of want like the Goldilocks. You don't want your classes to be too small. You want them to have enough functionality to provide something useful, but you don't want them to provide more functionality than is really necessary, because then you just end up with more responsibilities. It's a single responsibility principle. Anyway. And so unit testing is meant to sort of test the little things in your code, little things in your programs. However, your program is made up of multiple modules and multiple parts. And it's also important to be able to test those as they interact with each other. So you have maybe you have one method calling another method, or you have one class interacting with another class, or you have one subsystem interacting with another subsystem, right? Calling a REST API, or interacting with a database or a REST service or something like that. Anyway, and for those you need integration tests. And the whole idea is that this integrates multiple parts of your program and makes sure that that integration is doing what's expected. And so when and integration tests usually have a bunch more setup, they do more things, and they poke at sort of the outer parts of your program. Now, for these command line programs like Student, and as you'll see your project 1, we use integration tests to test the command line, right? So like, what does the command line do? You give the command line some command line arguments, and then it prints something to standard error or to standard out. Now, standard error and standard out, and the command line for that matter, are all the are things that are sort of like outside of the JVM, right? They are classes that your code interacts with. Anybody remember how to write to standard out in Java? System.out print line, right? There is an object called system.out. There's a system class. It has a static field out, and that refers to a print stream. What?
So simple.
Is it? Well, but it's consistent. You're right, because oh my God, it's the year 1994, and who writes command line programs anymore in 1994, right? Okay, you're still writing in 2019 in this class, but and unless you're, anyway, and so I would argue that it didn't make sense for Java to try to optimize for cout or anything easy like that. It's like, hey, let's have the principles be, or have the abstractions be consistent. So yeah, system.out.println is a little ugly, and then like 6 versions of the language later, you could just statically import out, and so it looks the same as cout. But anyway. Because your integration tests want to deal with these things that are sort of on the periphery, on the outside of your program, you interact with them a little bit differently. So the student project contains a class called StudentIT, which extends this class that I wrote called invoke main test case, which gives you some tools for working with the main method of a class and then interacting with the things the main method does, like writing to standard error or writing to standard output. So for instance, right now I have 2 tests that currently pass, and I can even run them to show you that they pass. The first one says, hey, invoking a main method with no argument has exit code of 1. And the way I represent this in the class is by having, well, I invoke this main class right here, and I say student.class, again it's the dot class. We'll see that later. And there are no arguments that are being passed. And I say assert that result. Now result is an object that is returned by this invoke main, which invoke main does magic that will run the main method and capture what is written to standard output and standard error. Give it all to you in an object that you can then interrogate in your assertion methods, in your assertions. So you can say assert that result.getExitCode equal to 1. And so what this does, if we then look at the main method of student, all the main does right now is it prints this to standard error and calls system.exit. But what the student integration test, that's what IT stands for, lets you assert that fact, lets you interact with that. So I also have a method that tests that when you invoke main with no arguments, it prints an error message to standard error. And so it has both of those. So now let's return to some of those test cases that we identified earlier that are more like that are more relevant to the main method than they are the other methods in the class. So when GPA is not a valid double, exit with an error message saying that GPA must be a decimal. So here, oops.
Why are you using assert that rather than assert equal?
Okay. Assert that is a very good question. Assert that is a method from a library called Hamcrest that gives you a bunch of more advanced assertions than what comes standard with JUnit. And so then I find that this is more readable because you get like methods like this equal to and stuff. This seems a little bit more natural to me than assert equals 1 comma result.getExitCode. It's just a little bit more readable. And then it can do things like, it handles things like arrays and lists and string contains. It makes it much more readable. We'll see examples of these. We might see some examples of these. Actually, we're seeing them right now, right? So here, assert that this error text contains string this. What do you need to do? You know, how would you do that with the JUnit assert? You would say assert equals. Yeah, you have to say assert equals result. Actually, no, you wouldn't even do that. You say assert true result dot get text written to standard error dot contains that string. You get better error handling this way than you do the other way. Anyway, if you go read the Hamcrest documentation, they make a pretty good argument for why you'd want to use that over the plain vanilla JUnit ones. A better argument than I can this late at night. Anyway, okay. So when GPA is not valid, print error message to standard error. Now, you might notice that I'm very verbose in the name of my my test methods. This is on purpose. I find that, like, wow, especially when you go back and reread your unit tests like months later, if like all this was like, you know, test invalid GPA, it's like, oh, what does that mean exactly? You got to really dig into the test. You know, there's no penalty for having big, long method names. And basically, it's a benefit because you don't need to write, you know, I could delete that comment, right? So I don't need to have a comment. I can just have a method name. And this way, if like the method were to fail in the report or whatever, I would have, you know, it would say the name of the method. I would need to go then and look at the source code to figure out what that method was trying to do. So, yeah.
Just more as an aside, is there anything similar to Cucumber about for Java?
Yes. So, I mean, there are lots of behavior-driven development, BDD, frameworks out there. What's that one in Groovy that I like? Sorry, what?
What is Cucumber?
Cucumber. Okay. So, remember how I was talking about the given, when, then, right? And the whole idea is that you've, well, okay. There are other frameworks that provide different languages for writing tests, and some of them are sort of table based. Let's say you've got a whole bunch of different scenarios. So let's see here for this one. Well, let's see here. I can't think of a good. Oh, maybe we'll at some point we'll validate different genders, and so maybe well, I guess there's sort of 3 options there: male, female, and then invalid. And this is for the sake of the class, not the sake of society. So you can have different different options there. You can represent your data differently, more tabularly. So yes, there are. I mean, so if you look for BDD frameworks for Java, there are a bunch out there. As a matter of fact, and I have an open issue at some point. Let's see here. I'll look at. There was one that I was thinking about using at the course for one point. Just haven't gotten around to introducing it. I have an issue for it here in my repository. What is it? BDD. Oh yeah, explore introducing BDD in the course. Oh, there's Cucumber JVM too. I don't know if it's like any good or not. But if you're a fan of Cucumber, you can use that. And there's also there's a JSpec instead of RSpec. There's Groovy. There's one in Groovy. What was the name of that thing? Spock is what it was. Minitest. Okay, yeah, yeah. There's tons of them out there. We sort of haven't coalesced on what is the best one. But yeah, there's lots of ones. And well, I don't know if it's something that if it's something that you really wanted to explore, we could figure out how to integrate it into the projects. But yeah, cool. Yeah, or yeah. Let me know how it goes. Where was I? All right, talking about integration tests. So let's write an integration test. So, okay, I want to invoke main, and the class will be student.class. And then, let's see here, the arguments are a bunch of strings. So remind me again, where's the student? There it is. What is the command line arguments again? Actually, you know what we'll get to that. Okay, so here it is. So it is name and gender and GPA and then classes. So the first argument is, well, it's name and then gender and then GPA, then classes, so class 1. Okay, and this is not a valid GPA. That is certainly not a valid GPA. So actually, I'm going to make it more readable. I'm going to put this into a variable and call it GPA. That's good. So now when I invoke this, I care about its result. And what do I expect to have happen? I expect 2 things. Well, actually, I guess all I'm expecting is so assert that result.get text written to standard error contains string what? Like invalid GPA. As a matter of fact, let's even have it issue the GPA as the message. So now when I run this test, it fails because it said I expected a string containing the invalid GPA, but instead it was missing command line arguments. Oh, with a new line, that's weird. This is the nice thing about the assertion, right? The assertion will actually, or rather the assert that, will tell you sort of what you expected. If you just did the JUnit, it would just say expected false when it should have been true because you didn't have all this nuance around contained string. So let's implement this. How are we going to implement this? Okay, well, first of all, so let's see here. What are the various command line arguments? So the first one is the name. The second one is the GPA. So this is 0, 1, 2. So string GPA string equals args2. 0, 1, 2. Okay. How do I tell if that string is a valid, what, double? Yeah, double is what we're looking for. So we want double GPA. How do we do that? Anybody remember? It is. Nice. Okay. So how do we then Right. So what do we? Let's see here. What happens when this fails? Actually, maybe we should just run it now to see what it is. Try catch. Right. What do you need to catch? Yeah, I don't know what it is either. Right. Yeah. Illegal argument exception. Number format exception. Of course. Okay. So then we'll wrap this in a try catch of a number format exception. And then what do we want to do? We want to say system.error.println, and then, oops, that was invalid GPA, and then GPA string. I'm pretty sure that's going to work. Yay! Okay. Good deal. So that's our student integration test. Okay, so we got that one running. Let's just run them all to make sure I haven't broken anything. I've broken things. That was my whole Bob impression. Array index out of bounds exception. Index 2 out of bounds for length 0. Which is this one? Oh, yeah. Okay, invoking main with no arguments. All right. So here I said args2. I passed it a 0 length array. It blew up with an array index out of bounds exception. Ooh, I know what I can do. I can just say if args.length equals 0, this code down here, oh, and I need to return. Well, I don't. The system.exit will, I don't know if I need that or not, because the system.exit will just exit the program. Right, you guys know about system.exit, right? Actually, do you? So exit exits the VM. Did you ever use the exit function in C? I don't know how much command line you've done. Maybe a couple of you have. Okay. Okay. Command line 101, also known as computer science in 1970, right? So Unix and other operating systems, but let's just say Unix. That's what everybody remembers. Command line programs. Yeah, command line programs have. So this is all the stuff in like page 254 of Kernigan and Ritchie, which you guys probably didn't. Did you guys like carry that around with you? Like that's what I did in college, right? So I had KNR, and it's like, oh yeah, there's all language stuff, and then like what you used every day was like the appendices in page 254 because it talked about standard I/O and standard lib and all that stuff. So the whole idea is that a command line program has various streams, pipes of information in and out of it, and there's and so then and also when a program runs, it has a notion of an exit code, which is a number that indicates, well, the program's over. What'd you think? And this is used to sort of convey the status of how the program did. So if the program is nice and happy, exit code 0 because this is C, and in C, if you say not 0, that's bad. So 0 is a Boolean, and 0 means basically everything was okay. Any other number that it returns is an indication that something bad happened. So like an exit code 1 means something went, something was bad, or there's some programs that'll be like 255, something is bad. Anyway, so it's got an exit code, and then also it has a notion of standard input, which is like data that is sent to the program from the outside, and then there's standard output, which is data that is sent from the program to the outside, usually the console, the terminal that you're working with, to convey textual information, like just stuff being written. And then there's standard error, which is textual information, usually textual information. It can be binary, meaning something bad happened. So standard input and standard error. Java, the Java virtual machine, is a command line program at the end of the day. And so it has these things like an error code, like standard input and standard output and standard error. And they're all referenced here. So anyway, so basically what this is saying is like, listen, in my main program, my command line program, if I wasn't passed any arguments, print an error message to standard error and exit the Java VM with an exit code of 1. And so I did that. And everything passes now. This is cool. So now we've written our first integration test for our command line program. We have added a bit more functionality, and we have verified that functionality is what we expected because we wrote a test first, and that test now passes. So let me just put that here. I'll commit it, and I'll say we wrote our first integration test. And push that up to GitHub. Okay. Oh, and we already have this test, I guess, when there are enough command line arguments exit with an error message. Okay. So here's something, going back to the assignment. The ultimate test case, right, the thing that is listed here, ultimately where you want to get to with this program, is that when you run the command line with these command line arguments, it prints out this string right here. So let's write a test that does that. So let's see here. When command line arguments, well, no, let's see here. When when command line arguments from assignment, well, command line arguments from assignment print expected student information. So let's see, here's the invoke main. Oh, well, I'll do something else later. Student.class, and then all of those. Well, actually, I didn't want to do that. Yeah, that'll be fine. I just got to turn that into a bunch of strings. Algorithms. So when I invoke with all of these command line, with this command line, oops. I expect that result.get text written as standard error actually is equal to this big string right here. Oops. And you know what? I'm going to assert that result.get exit code is 0. Now, this clearly should fail because let's see here. Nothing was written to standard error or standard out, which I'd expect. What doesn't it like here? Oh, that's where. Oh, nice. It's telling me which assertion failed. That's super nice. So clearly, this test. I mean, this is like the last thing that I expect to pass, right? We need to implement all the other functionality before we get this test to pass. So this is a good test. It's just that it's not going to pass for a long time. So what JUnit allows me to do is if I add an @ignore annotation there, it says, yeah, the test, let it compile, which is good because if I change the API, I still want it to like be updated and stuff. But it won't actually run it until I remove that @ignore. So now if I run all of the tests here in my StudentIT, it notes that, hey, I ignored the command line argument from the, this big old ugly one because it was @ignore, but the rest of them pass. This is cool. This is good. And then what this allows me to do is determine when I'm done. That's a really important aspect of testing. So one of the things that your tests tell you is when you're done, right? How do you know you finished your assignment? You finish your assignment when you can't think of any more tests to write. Any more new and unique and interesting tests. So it's not really about getting your code complete. It's about getting all your tests to pass, making sure that your tests are complete. And so I know that, well, if I can get that to test, now this doesn't do any error handling, so we also need to test error handling and stuff. But we know that, all of the happy path functionality will be complete when that test passes.
Is the ignore just one line below or anything below the ignore?
It is, these annotations are a very good question. So these annotations, because they precede this method right here, they are associated with that method, and so they will ignore. So yeah, they're associated with that method, so that's the method that will be ignored. Yep. Good question. Okay, so let me add this real quick. Okay, we add the ultimate integration test. Add the ultimate integration test, but ignore it because it will be a while. Oops. Okay. So, what have we seen tonight? So far, with the student assignment, we've seen how to create it, how to open it up in IntelliJ, how to edit it, and how to do test-driven development both on the unit at the unit level and then at the integration level. This is all against the student class and the student project 0, which is mainly for demonstration. Right? I encourage you to do it on your own, but this is not something you submit. This is not something that's for a grade. Now, let's talk about what does count for your grade, and that is project 1. Okay. So there's a 5-phase project in this course, and this is the first phase of it. This is project 1. And what you'll be doing is implementing an appointment book. And so appointments have multiple properties, multiple attributes, and they are all stored in an appointment book. In this first assignment, you'll be writing the fundamental application classes for the project. And so this is a class called appointment and a class called appointment book. And these are going to be classes that you work with throughout the rest of the course. And so then you'll be adding to it, you'll be changing things as the assignments evolve. And this is a pretty simple project conceptually, but really what it's meant to do is get you used to using code that you didn't write. These classes will extend my classes, and so you'll have to understand how to work with code that I wrote. And it'll also get you used to working with the command line, building with Maven, all of that good kind of stuff. So I'll get some highlights from the assignment, then we'll go and create the project, and we'll start from there. So I provide you, so for the projects, there's a package called edupdx CS410J, which has all the classes for the projects. And there are 2 abstract classes. Do you remember what an abstract class is in Java? Tell me what an abstract class is in Java. Sorry, Jackson. Right, you cannot instantiate it. Why is this interesting? Why would you have a class you can't instantiate?
Be a base class for something.
A base class, right? So it's sort of a partial implementation. You have a category of class that provides some amount of common functionality, but then some of that functionality, some of that implementation is delegated to specific instances of the subclass. Well, in this case, each one of you is going to extend my abstract classes and provide some new functionality on top of it. So you'll inherit some functionality from my classes, and then you'll all be adding additional functionality to your own classes. So there's abstract appointment book. Now, the abstract appointment book has some properties. Each appointment book belongs to a particular owner and consists of multiple appointments. And each appointment has some properties such as a description, and a begin and end time, and a begin and end time, I guess. That's all. Now, note that for this first assignment, the begin and end times, and it's a date and a time, should be represented as strings, or at least, yeah, represent them as strings for the first assignment. You don't have to look ahead and learn how to use Java date or anything like that. You can if you want, if you're familiar, if you want to go ahead, that's totally cool. But for this first assignment, dates should be represented as strings. That's all that's necessary. So you've got an appointment book class and an appointments class. And then there's another class called Project 1, and that has your main method that drives all of this. Now, Project 1 is a command line tool that will parse the command line. If the command line is valid, it'll create an appointment book and then add an appointment, which is also specified on the command line, to that appointment. If the command line has a print option, then it should print a description of the appointment by invoking its toString method. And so here is the command line interface. So you'll run your project 1 method. The command line has options that are optional. And then it has command line and it has program arguments. And for this assignment, there are 4 program arguments. There is the owner. There's the owner of the appointment book. There's the description of the appointment, the begin time for the appointment, and the end time for the appointment. And both of these are in 24-hour time, and the format for that time is month, date, year. So 2 digits, 4 digits, hour, and minute, again in 24-hour time. Now, preceding the command line to the program arguments are options. And so the first one is print, which will print a description of the new appointment book by invoking its toString method. And the other one is a -readme that will print the readme for the project and exit. I'm going to go into detail about the readme next time. There is a handout if you want to look ahead, but we've already covered plenty tonight. I'm not going to go into those details. Next week we'll talk about details like what the readme is, what documentation you need to provide, and then how to submit it. All necessary things, but I've already packed in plenty for tonight. So this is what your command line ought to look like. Note that we're running things on the from the shell, and so then if you have command line arguments that have consist of multiple words, you should put them in double quotes. And here are some examples of valid dates and times. I guess it can be 1 or 2 digits. Oh, there's also something called a plan of attack, a POA. We'll cover it again next time. So this first assignment has very little logic in it. As a matter of fact, a lot of students find it disappointing because it's like, what? All I do is read the command line and create an object, put it in another object. Yeah, that's all you need to do. That's plenty for the first assignment because it's really more about just sort of figuring out how to use Java, figuring out how to use IntelliJ, and getting an experience writing unit tests. And so a big part of the assignment and a big part of your grade for the assignment is going to be error handling. Right? If something's missing from the command line, if something isn't, if the date isn't formatted correctly, if you have extra stuff on the command line, if the description is empty, all of these kinds of things are what you should be checking. And yes, this is the purpose of Project 1, to get experience using Java to do command line parsing. Right? Not super exciting necessarily, but it teaches you a lot. Don't worry, we'll get to much more interesting stuff later in the term. Submit all of your source code. Some of this stuff isn't as interesting anymore or relevant. Again, here's information about the Maven archetype. Luckily, all of this has been taken care of for you in by the magical scripts. So, once more with feeling. Do I have any changes? Oh, look, I have more stuff there. That should begin to get ignored. I will. Oh, app. Yeah, I'm not sure if that should be get ignored or not. I can't remember. It probably should. Anyway, what am I doing here? I am going to then use the create project 1 script to create me project 1. Now, project 1 has essentially the same properties as project 0. It's a command line application. You create it with the script. It has unit tests. It has integration tests. So I show you project 0 so that you can apply those things in your project 1. I'm not going to do your project 1 for you in front of everybody. I'm going to do the little toy student project instead.
When we add the XML to our settings, .xml and M2, do we replace the project 0?
Nope, it's all the same. Sorry, yeah. So you only need to add the settings.xml once.
Oh, okay. So
yep.
This stuff is.
It's irrelevant now. Yeah. So sorry here again. I didn't update the PDFs when I did that. So yes, that's a very good point. Once you have updated your, as a matter of fact, if you go and look at it, it's the same XML in Project 0 and Project 1. So I can now that created a appointment book directory with our old friend the Maven wrapper. And now if we say Maven wrapper verify, this will do all of the good stuff. So it'll compile the code. It will run the tests, all of the tests, happily. Okay, good deal. So now I'll do I'll do a Maven clean to get rid of all that stuff. Then I'll do a get add of appointment book. That is all good. added empty project 1. Nice. Okay. And now, okay, now let's open up an IntelliJ. So I'm basically doing the same thing I've already done like 2 other times tonight for a partition. Appointment book, open up the POM, open project, new window. Okay. And we've got, all the same stuff. We've got, actually we got a couple different things. There's an appointment class, which again extends my abstract appointment, and all of these methods are, either explode when supported operation exceptions, or return probably the wrong string. Project 1, we have a very simple implementation that simply prints out missing command line arguments and then any arguments that are passed in. And then we've got unit tests and we've got integration tests. They go off and play with some things. Slightly different than what you get with the student project, but I hope you are familiar enough with the concepts, or can be by after you watch the video again, that you can then that you can then start working with them. You can use the command line to build the executable jar. And let's see here, with some command line arguments, and then if we say 1, 2, 3, it prints out 1, 2, 3, which is exactly what the main method does. So this is your project 1. Your project 1 is due in 2 weeks. One of the things that I need to tell you on the first day is that things come fast and furious. Project 1 is due in 2 weeks, but next week you're going to get project 2, and it'll be 2 weeks after that. Project rate, you sort of, you've got a lot of stuff sort of going on in progress and in parallel. In 8 weeks, that's sort of what we got to do. I don't want to give you just 1 week to do it, because you might need some time to figure something out or whatever. But it does mean that you need to get started soon on these things. My experience, the students that have struggled most with the course isn't because the material's that hard, it's because they didn't manage their time appropriately. And I've seen the ones who have been the most successful are the ones that get off to a good start, and then by week 4 they're comfortable working with the environment, because things will ramp up and get more challenging a couple weeks in. Any questions on project 1? Yeah.
If you import from the POM XML into IntelliJ before you do Maven verify, is there any problem?
A lot of people have had problems with that, actually. So, I've helped a couple of students, well, this term and in other terms, where they open up their IntelliJ, and IntelliJ has all this read over because like, I can't find this class, and where's this abstract appointment book class, or what's this JUnit thing? One thing that I need to make more clear in the README for like getting started is that before you open up IntelliJ, run Maven verify. That will make sure that your command line environment is configured. Maven verify also goes and downloads a whole bunch of stuff. Right, the first time you ran Maven, it went and downloaded like the entire internet to your machine, right? I mean, it spent minutes downloading a whole bunch of stuff, or maybe lots of seconds downloading a bunch of stuff. This is because there are lots of dependencies, both for Maven's own needs and then also for the project. When you download all that stuff, that stashes it all away somewhere under your home/.m2 directory. And IntelliJ knows to look for all of that. And that's where it'll look for all of the libraries. If you open an IntelliJ before you've downloaded all those libraries, IntelliJ will be confused.
So if you do that, what are the ways to, like, how do you...
Run Maven to download the libraries, and then you got to blow away your IntelliJ files, which is the .idea directory and the .iml files.
Okay.
I know you're asking for a friend.
Yeah.
Yeah. We've all been there. Had a friend. Okay. Anything else on project 1? Okay. Well, let's see here. We talked about the syllabus. Talked about Project 1. Talked about the cones. Uncle Bob. Getting started. A couple more things. So GitHub, it looks like a lot of you have used it already. They have their student pack. I recommend that you take advantage of it. These are professional software engineering tools. This is the kind of the cool thing about the time we're living in now. Companies are realizing, more so than ever, that it makes sense to empower people like you to use their tools. Because guess what? A couple of years, you graduate, you're out there in the real world. What's on your resume? GitHub. And so, like, well, I want to be able to, attract high-quality students from Portland State. I should be using GitHub too. By the way, we use GitHub at Tripwire. GitHub Enterprise. We have our own hosted instance. We don't put our source code out there for everybody to see. Well, that's like our business. That's our intellectual property, right? And this is how we. Like we want to be able to use the open source tools, but we still want to keep our source code in a place where we can control it. Because someone steals our source code, and that's our business right there, right? Yeah. So anyway, not that you want to see our source code. A lot of it's really messy. But anyway, and a lot of it's really beautiful too, boss. Especially the code that you wrote 10 years ago. Anyway, so I recommend that you recommend, not required, but I recommend that you use GitHub. IntelliJ, also a great tool. Hey, if you want to use something like Eclipse, anybody still use Eclipse? Go for it. I can't support you though. I gave up. Oh my gosh, Eclipse. Yeah, no. So IntelliJ is worth paying for. And also, if you want to learn more about Linux, the cat has good stuff there too. Finally, so Jim Shore, Portland's own Jim Shore, has a really great series of videos up about test-driven development. If TDD is something that you're really curious about and really sort of want to understand and really get into, I think this. And if you learn well from watching people code, which if you're in this class, get what you're going to do, watch me code. Jim's videos are really good. He sort of goes step by step. You'll see his thought process. You get to understand what refactoring is all about. You get to see how his approach to the solution evolves over time. There are a lot of episodes, but I think it's worth it. So I recommend that you integrate that into your into the material. In this class, we don't have a textbook. This isn't one of those classes where it's like, okay, this week we're going to cover chapter 9. It just doesn't work that way. So instead, what I'm doing is I've sort of curated a bunch of information, pointing you to videos and pointing you to resources that are all out there and all out there for free, so you don't have to buy a textbook. Instead, you're spending your time to explore what's out there. Okay.
When do you post screencasts for the classes?
As soon as I can. It's late at night right now, so I don't think I'll get them out tonight. Plus, there are like 3 of them and stuff. Let's see here. What do I got going on tomorrow night? I'll try to get them out by tomorrow night, and I will. I'll post it to the general channel. What are they called in channel? Yeah. We use MS Teams at work, so there's like different things. General, the hashtag general channel on Slack. Okay then. With that, I think we've covered everything for. Oh yeah, question. Sorry. Yeah.
Maybe you covered it, but I didn't listen. The quizzes, are they going to be based on more similar to the cone style, or? No,
the quizzes are mostly, well, the quiz one's a little different, but the quizzes that are on class content are qualitative. A lot of them are like, tell me about some API or something like that. I think I wrote them a long time ago. Yeah. But quiz 1 is due next week. It should be available now. Let me know if you have any problems. So, everybody's mumbling and getting ready to leave because, my God, it's 9 o'clock at night. So, I'll see you again next week, I hope. Thank you for turning in all of your cards and everything. I'll let you know who's available. Bye. Okay, wait a second. I need to stop this. I don't want to stop.